This problem says find an equation for the line with slope 6 and x-intercept -2. So to write down what is wanted, equation of the line. What is given? We got slope and x-intercept. So remind yourself what x-intercept means. On a regular 2D coordinate axis, this is the x-axis, and this is the y-axis. Let's say that a given line looks like this. I'm not talking about this particular problem. I'm saying any given line. And if you take a minute to look at this picture, where is the x-intercept and what is it? And where is the y-intercept and what is it? Pause the video if you need to think about it. All right, since this is the x-axis and intercept means to cross, then this right here would be the x-intercept. And where the line crosses the y-axis would be called the y-intercept. So we don't know what exact point on the x-axis the line crosses at, but we do know that the x-axis and the y-axis cross each other where their respective coordinates are 0, because we know this point right here is the origin, 0, 0. So what is the y value of the x-axis? Anything that is on the x-axis, say this point right here is on the x-axis. If I said the x-axis and the y-axis cross at 0, 0, then what does that mean? That a point on the x-axis, what does that mean its y-coordinate is? Well, it means that the y-coordinate must be 0. Let's say this was at point A, where A is some number. That means that since A is on the x-axis, or you could say A intercepts the x-axis, is at, let's call this point P. P is, remember the first coordinate is the x coordinate, and the second coordinate is the coordinate on the y-axis. So when it says that the x-intercept is at -2, remember, it's on the x-axis. It's intercepting the x-axis. It's the x-intercept right here. That means that we can infer another piece of information that's not explicitly stated. We know that the y value at this point is 0. So sometimes from what you are given, you can conclude some more information. So instead of just saying x-intercept, since we were given the x-intercept, we can say, we now know that a point on the line, we don't yet know an equation of this line, but we do know that it passes through the point -2, 0. And also, we know the slope, which is often written with the letter M, that's just convention by now, is 6. So now we have a point and a slope, and we need to figure out what's the equation of the line that passes through this point and has this given slope. And now what we'll see is that there is a form of equation just for lines for which you have a point that the line passes through and the slope that the line has. Let's say that this is the line we want. Call it lowercase l. And we know that this point is on it. Okay. And I'm just going to write the slope is 6. An equation of the line. You want to know how to calculate some other point on this line, any other point, but let's say the point you're interested in, where this one, where we use x and y as the coordinates of some other point on this line. This type of equation is called the point slope form. Okay. How do we do this? Well, we're saying that we know the slope. Let's say that this point right here that we know is at -2, 0. And this is the point that we're interested in. And we know that this slope right here is 6. That means that the slope, which is the ratio of the rise over run, is going to be 6 in this case. There's one other thing we need. We can say that this distance is going to be the difference between the y coordinates. This one's y coordinate is y. And now look, we don't have this point, so we know that this point's y coordinate is 0. And since this part is completely flat, we now know that its y coordinate is 0. Now, we know that the run is the difference between the first number and this -2. So we know that this is the difference between x and -2. And this will be x. So now we're going to write y minus 0 over x minus -2 is the slope of 6. Well, minus is plus, so we can say y divided by x plus 2 equals 6. I'm going to erase everything right here and write. This is the equation. We know that the y over x plus 2 equals 6. But the form that is most often used to write the point slope form, we're going to move this over to this side. We're going to keep this right here. And we're going to write y equals 6 times x plus 2. This is the answer to this problem. This is called the point slope form. This problem states if a line has non-zero x and y intercepts, a and b, prove that the equation x over a plus y over b equals 1 is an equation for the line. So I encourage you to stop and pause this video and look at this equation and say, what is my plan for verifying that this is a equation for a line as described? Think how you would prove it. Okay, this is how I would prove it. I would start with an equation that I know is a true equation for the line and see if I can transform it into this equation. First of all, let's figure out what the a and b, x and y intercepts. Let's say that this is the x-intercept, this is a, and this is b, because the x-intercept crosses the x-axis, and the y-intercept crosses the y-axis. Okay, now the line between these 2 points would be this line. Okay, so what I have here is 2 intercepts, and ask yourself, what forms do you know for equations of a line? One of them is called the slope intercept, and that looks like y equals mx plus b, where m is slope and b is y-intercept. Another form is called the point slope form, where if you know that this point is on the line, call it p x1 y1, and you know the slope is some slope m, then the point slope form is some y value that you're interested in minus y1 is equal to the slope times the x that you're interested in minus the points x, x1. So this is the point slope form. This is the slope intercept form. Now, given this description, we have 2 intercepts. Do we have any particular points? Well, you could say that this is point 0b and this is point a0. You could try using this, but I'm going to start with the slope intercept. But what's the problem so far? What do I lack before jumping in and using this? Do I have b? Yes. Do I have m, the slope? Not exactly, but I have all the information I need to get it. Let's draw a triangle here with rise, with this is b, and this is a, because this is 0, 0. Now, as the slope is traveling in this direction, what is the change in rise? It's actually minus b. I'm going to say the slope is, because it goes down b, if we consider b to be a positive number, and it goes forward a. So there we go. We can say that the slope m is minus b over a. Okay. So Let's write this line as the slope-intercept form, substituting negative b over a where you see m. Then we have y equals negative b over a times x plus b. This is the slope-intercept form. This is the slope. This is the y-intercept. Okay, I'm going to make some room here. Now the goal is to see if this is a valid equation. We should be able to convert another valid form into this form. So look at this for a little while. Pause if you want to. What do these two terms have in common that we can factor out? See, they both have a b. So let's do that. Let's use the distributive property and bring the b to the outside. And what's left when we factor the b out of this, we still have minus x over a plus, if we factor a b out of a b, what's left is 1, right? I'm going to erase this now. Now, what can we divide both sides by to get this by itself? B, right? We're going to divide this side by b over b, so they cancel out. But we divided this side by b, we got to divide this side by b. So now we can write y over b equals, this is all that's left. I'm going to get rid of the parentheses. We're going to say minus x over a plus 1. Now as you look at this, we're almost there. Compared to this, what would you do? We can add x over a to both sides. So we have y over b plus x over a, and on this side we have minus x over a plus x over a, so it cancels out and we're left with 1. And with the commutative property of addition, this is the same as x over a plus y over b. So there you go. We proved this by starting with the point slope form, and we figured out what the slope was given the intercepts that we had, and we transformed it into the target form, which is known as the intercept form. So now we know 3 different ways to make lines. We have the point slope, the slope intercept, and the intercept form. One thing you could try is converting the point slope form into this form. I encourage you to try out that. Okay. This problem says find an equation for the line passing through the point 7, -3 and perpendicular to the line 2x minus 5y equals 8. Look at this form of equation of a line. This is called, sometimes it's called the general equation of a line. It looks a lot like the intercept form, which, if you watched the previous problem, was like this. You might have x over a plus y over b equals 1, and this is the x intercept, and this is the y intercept. So in this problem, they haven't told you exactly what the slope of the the desired line is, but they told you that it is perpendicular to a line with this equation. And so in your strategy, you've got to figure out from this what this line's slope is. And you know that it is perpendicular to, we'll call M prime, the line that you are interested in. And here's a point where you need to know another theorem of perpendicular lines. Let's say this is M, and this is a line with slope M prime, and they are perpendicular. Now, we won't prove it in this problem, but there is a theorem that says when, if and only if, two lines are perpendicular, the double arrow means if and only if, means if you know this, then it's true that the product of the slopes is -1. This is a theorem that we will use if we know that the slopes, the lines, are perpendicular. Let's say this is line L, and this is line L prime. If lines L and L prime are perpendicular, then the product of their respective slopes is -1. Also, if you know that the product of the slopes is -1, then you know that the lines are perpendicular. I encourage you to look up a proof of that theorem, but we'll take it and use it. But first of all, we need to know the slope of this line that we've been given. You could figure out how to turn this form into the slope-intercept form, which is y equals mx plus b. You could figure out a particular point on this line, and you could use the point slope form. But what I'm going to do, I'm going to try to convert this form into the intercept form. Okay. So first of all, let's write it. Okay. Let's divide both sides by 8. Then this becomes 1. And this, the sum or difference of a fraction, can be written as the, well, we can put the denominator on each one. But this isn't exactly in the form x over a plus y over b equals 1 just yet. See if you can pause the video and figure out what a and b are from this before you watch me do it. See if you can do that. Oh. Now, 2x over 8 is the same as x divided by what? So a, the x-intercept, is going to be 8/2, which is 4. And it divides by -5/8 is the same thing as dividing by -8/5. And what I've drawn here is the x-intercept and the y-intercept. Okay. Now at this point, at the y-intercept, the line is passing through 0, negative 8/5. And here at the x-intercept, the line is passing through 4, 0. So from here to here, the rise has been an increase of 8/5, and the run has been an increase of 4. And the slope is the change in rise, 8/5, over the run, which is 4. 8/5 over 4 is 8/20. So the slope of this line, we can cancel out 4, 2, it's the same as 2/5. So now we know the slope of this line. The slope of this line is 2/5. You notice the slope is positive because it's going up. Now remember that theorem of perpendicular lines? We're saying that 2/5 times the slope that we want is equal to -1. So what does that mean that the slope of this line has to be? 2/5 times what is -1? In that case, the slope of the line is going to be -5/2. Now we have a point and we have a slope. We can say the point 7, -3, and the slope -5/2. We have a point and a slope. Which is the most natural equation for a line to use? Would you use the slope intercept, or the intercept form, or the point slope? The point slope is the easiest, and they didn't state in this problem which form to put the equation of the line in, so we might as well use the easiest one. We can say that y minus -3, so let's just rewrite this. We can say y plus 3 equals, what's the slope? -5/2 times x minus 7. And this is the equation in point slope form of the line that passes through 7, -3, and is perpendicular to the line with this general slope of a line, general equation of a line. So this is the answer. This problem says convert the equation to slope-intercept form and sketch the line. So here's this equation, and we have to convert this to slope-intercept form. So what does that look like? Do you remember the form of what slope-intercept looks like? If that is y equals slope m times x plus b, and b is the y-intercept. So try doing this on your own. Pause the video, get your answer, and then unpause it, and I'll show you my way of doing it. Okay, first I want to get this all by itself on one side of the equation, so I will add 5x to both sides because we got a minus 5x here. So then we got 2y equals 5x plus 1. And then to get y all by itself, we need to divide both sides by 2. So if we divide 2y by y, we get y. Now all of this over 2, we can break it up and say this over 2 plus 1/2. So y equals 5/2 x plus 1/2. So this is the slope-intercept form. Let's erase something to make more space. Okay, here's the coordinate axis to sketch this line. The y-intercept is at 1/2. Let's do this. 1, 2, 3, say 1, 2, 3, 4. The y-intercept is at 1/2. So let's draw a point halfway to 1 right here. Okay. Now what is 5/2 in decimal? It's 2.5, right? Or 2.5, 2.5. So that means every time x increases by 1, the rise is positive 2.5. So if it's at 1/2 right when x is 0, then by the time x is 1, it's gone up 2.5. Here's 1/2, 1, 2. So by the time it's at 1, x is 1, y is 3. So we've got 2 points right here, 0, 1/2, 1, 3. Okay? So given 2 points right there, incidentally, another way of doing it would have been to say, where does it cross the x-axis? Well, at the x-axis, y is 0. So that means that 5/2 of something plus 1/2 is equal to 0. We can bring over the negative 1/2 to both sides to cancel this out. Okay. And we want to find out what value of x is it crossing the x-axis. We want to get x by itself. What can we multiply both sides by? What do we multiply 5/2 by to get just a 1 right here? 2/5. Right? So negative 1/2 times 2/5 is the x value. So 2's cancel out. So negative 1/5 is it's actually better to have the x-intercept and the y-intercept, because that way we can tell where it crosses each axis. So if this is negative 1, it's about 1/5 of the way to right there. It's very close. So that's we can honestly say that's a very bad sketch. If you had some graph paper and you did it with really nicer scale, then that would be much better. But anyways, this is the equation in slope-intercept form, and we did a sketch, and that was what the problem wanted. This problem says, find equations for the altitudes of the triangle with vertices A, -3, 2, B, 5, 4, and C, 3, -8. and find the point at which they intersect. Well, something important for this problem is to know what an altitude is. So first we'll look at that. So an altitude of a triangle is a line that passes through a vertex of the triangle and the line that is perpendicular to the side opposite of that vertex. So in this case, we're talking about this particular vertex, and here is the side opposite of that vertex. The altitude is the line that passes through that vertex and is perpendicular to the side opposite that vertex. As you can see, the triangle has three different altitudes. We could call this one A1. And if this were vertex B, then the line that passed through B and was perpendicular to this side, which is the side that is opposite of vertex B, we could call this altitude 2. And if this were point C, the line that passes through point C and is perpendicular to this side opposite of vertex C, we can call that altitude 3. So we need to find the equations for these three altitude lines and then find the point at which they intersect. So first, let's solve the equation of altitude line A1. A1 passes through the point -3, 2, and it is perpendicular to line BC. So you have a point, and do you have a slope yet? Do you know what the slope of this line is? If not, do you know how to find it? Why don't you pause the video and figure out what the slope of line BC is. So we want to find the slope of this line. And the slope is the change in rise, or y, over the change in run, or the difference in x. So here we got the y value and the y value. So I did 4 minus -8, and I divided that by 5 minus 3, which is 12 over 2, or 6. So that means that this line has a slope of 6. Now A1 is perpendicular. And do you remember the theorem about what is true about the slopes of lines that are perpendicular? Let's call the slope of A1 M sub A1. And the slope of this line, as we just figured out, is 6. And what is the product of the slopes of perpendicular lines? Remember, that's a theorem. It's always -1. So what times 6 equals -1? This means that the slope is -1/6. So now we know that the point is -3, 2, and the slope is -1/6. Do you have enough information to figure out the equation of this line? You have a point and a slope. Which form of line is obviously the easiest to do? let's do the point slope. Remember, the form of the point slope is the y minus some y1 that you know is equal to the slope times x minus the x1 that you know. This is the point that we know, so we can say y minus 2 equals slope negative 1/6 times x. Now, minus negative 3 is the same as plus 3. Okay, this is the equation of altitude line A1. So we've got that now. The next altitude line we want to solve is this one, the one that passes through the point 5, 4 and has a slope which is perpendicular to the line between the points negative 3, 2 and 3, negative 8. So first we need to find the slope of the line between these two vertices. So the slope is the difference in y. So we got negative 8 minus 2 over 3 minus negative 3. Negative 8 minus 2 is negative 10. 3 minus negative 3 is 3 plus 3 is 6. Negative 10/6, which if you divide both top and bottom by 2, negative 10 divided by 2 is negative 5. 6 divided by 2 is 3. So that means the slope of this line is negative 5/3. Now we want to find the slope of the altitude line, which is perpendicular to that line. Negative 5/3 times what is negative 1? Because remember, the theorem is that the perpendicular lines slopes have a product of negative 1. Negative 5/3 times what? 3/5. So that means that this line has a slope of 3/5, which you can tell that the drawing is not drawn to scale. But fortunately, that doesn't matter in this case. Now we know the point 5, 4 and the slope 3/5. Now we just have to write it in point slope form. We'll call it A2. You remember the form of the point slope? You do y minus the y value of the point that it passes through, 4, equals, what's the slope? It's this one, 3/5 times x minus the x point that we have is 5. So this altitude line has the form equation y minus 4 equals 3/5 times x minus 5. There's one last altitude line to solve for, and that's this one, A3, the one that passes through the point 3, negative 8, and has a slope that is perpendicular to the side negative 3, 2, and 5, 4. So by now, if you've been following along, you should see that we want to find the slope of this line. Let's do that right now. So we've got 5, 4 and negative 3, 2. That's the difference in y. It's the 4 minus the 2. Right? 4 minus 2 is 2. And we're going to talk about the difference in x. 5 minus negative 3 is 5 plus 3, which is 8. 2/8 is 1/4. That's the slope of this side. Now the slope of this side, we're going to say 1/4 times what equals -1. You can tell that the slope of this line is -4. So now we know the slope is -4. And so to write in point slope form, try pausing right now and see if you can write the point slope form of the line that passes through 3, -8 and has slope -4. Remember, it's y minus what's y minus -8? That's the same as y plus 8 equals, the slope is -4, and it's x minus 3. So now that is the third altitude line. So now we have solved for all 3 equations of the altitude lines. So to solve this point right here where these 3 lines intersect, this is a system of linear equations in 2 unknowns, x and y. So really we only need 2 equations of lines. We have 3, so we can pick any 2 of these to solve for the 2 unknown variables. You can choose which ones you want. I've chosen this one, A1, and this one, A3. I'm going to find out where these intersect. And the way I'm going to do it is I'm going to write these equations right here. Y plus 8 equals -4 times x minus 3. And then I'm going to write this one right here underneath it, y minus 2 equals -1/6 times x plus 3. And which one of these do you think is easier to cancel out by addition or subtraction of one of these by the other? See how the x is kind of buried inside of this. So what we'll do is we can subtract, we'll call this equation 1. We can subtract equation 2 from equation 1. And now we've got y minus y is nothing, it cancels out. And we've got 8 minus -2, which is 8 plus 2, which is 10. And now for this, what you really need to do is carefully on paper or using a calculator that can handle rational numbers. First, you need to distribute the -4 over the x minus 3. And then you distribute the -1/6 over x plus 3. And then you can subtract the minus -1/6x from the minus 4x, which would be -4x plus 1/6x. And then you'd have the -4 times -3 is 12. So once you do all this and you do these subtractions, what it ends up being is -23/6 x plus 25 halves. Now, what this ends up being is once you subtract 25 halves from both sides, what you've got is -5 halves equals negative 23/6 x. And then what x ends up being, if you do the math carefully, x is equal to 15/23. So the x coordinate, the horizontal location of this point, is 15/23. And now, since we have the x coordinate of this point of intersection, what you can do is plug in that value in any one of these other equations of the line, because they all intersect, and find out what the corresponding y value is. If you want to, you can pause the video and plug in 15/23 in any one of these and then solve for y. And so if you plug in 15/23 into any one of these, I chose A3, and as you can see right here, I substituted that for x. And if you follow the arithmetic through, y comes out to be 32/23. And this point of intersection is then 15/23, 32/23. If you plug this into if you plug these three equations into a graphing calculator and plot this point, you do see that this point lies at the intersection of these three altitudes. This problem says find all values of t such that the value of the slope of the line through 3t plus 1 and 1 minus 2t is greater than 4. So we're talking about a slope, and we've got 2 points. You remember the slope formula? Yes, it's the distance. It's the difference between the second numbers over the difference of the first numbers. So we could write the slope is equal to, we'll take this one as the first one. So 3t plus 1 minus t over, or if we take this one as the first one to subtract from in this top numerator case, then we got to take this one as the first one in the denominator case. So we got t minus 1 minus 2t, and we're saying that we want the slope to always be greater than 4. We can simplify this. Instead of saying t minus 1 minus 2t, we can do t minus 1 plus 2t. Now how can we simplify the numerator? 3t plus 1 minus t. We group the likes. We got a 3t and a minus t. So what does that make? That makes it a 2t. Now we've got t minus 1 plus 2t. We group the like terms. We got a t here and a 2t. They combine to be a 3t. We can put that over here. Now I'm going to move this over. Is greater than 4. So if you've seen these types of problems before, inequality problems, if you've watched my video or another one, what do you have to be careful with when multiplying both sides of an inequality? Think about that. What if 3t minus 1 is a positive value, given the t in question? We multiply this side by 3t minus 1, we cancel out, and we have 4 times 3t minus 1. If this is a positive number, it's fine, right? But what if you chose a value of t such that 3t minus 1 was a negative value? What happens when you multiply both sides of an inequality by a negative value? What happens to this inequality symbol? It flips. So that's why you have to be careful. Another strategy is what? Do you know? What we can do is, if 2t plus 1 over 3t minus 1 is greater than 4, then if we subtract 4 from it, and it's greater than 0. Why did I do this? Well, watch this. We'll see. Now, if we want to combine this, what do you get? We can say 2t plus 1, and then we're going to put 3t minus 1 minus 4, and if we put the 3t minus 1 over 3t minus 1, that's fine, because 3t minus 1, as long as 3t minus 1 is not equal to 0, but we have this case anyway. And we combine then what can we do? Okay, I've distributed the minus 4 over the 3t minus 1. So now we have this. Now, group the like terms in the numerator. What do you get? You got 2t and minus 12t. What's 2 minus 12? Minus 10t. What about the numbers? The 1 and the 4 is 5. And you got 3t minus 1 is greater than 0. So after all of this work, now we have something that is greater than 0 rather than greater than 4. Why do you think we have done this? For this to be positive, greater than 0, what do we have to have? Do you know? We have to have either the numerator and the denominator to be positive, or the numerator and denominator to both be negative, right? Because if the numerator is positive and the denominator is negative, this is going to be a positive divided by a negative, which is a negative expression, and this won't be true. If we have a negative numerator and a positive denominator, then this won't be true. So now we want to find out if there are values of t where this is both positive and this is positive, or if there are any values of t where this is negative and this is negative. It might be that one of these is inconsistent, as we'll see. Let's try to figure out what values of t make negative 10t plus 5 positive. Okay. Now, let's add 10t to both sides. So we've got 5 is greater than 10t. Okay, to get t by itself, we divide both sides by 10. 5 divided by 10 is 1/2. So t is less than 1/2. Okay. Remember what this is for. This is for making the numerator positive. Now, we want to see what values of t make 3t minus 1 also positive. 3t minus 1 greater than 0. We want to get t by itself. What can we add to both sides? Well, to get rid of this, we can, on the left side, we can add 1 to both sides. Then we've got 3t is greater than 1. Okay. To get the t by itself, what do we do? Divide both sides by 3 to cancel out this 3. So now t is greater than 1/3. Now we take both of these together, since they're both present in this fraction. Can t be greater than 1/2 and 1/3? Of course. What values of t make these both true at the same time? What's bigger? Oh, I made a mistake. On this one says that 1/2 is greater than t. So t is less than 1/2. Let's draw a number line. Here's 0. Here's 1/3. Here's 1/2. So look at what this one says. T is less than 1/2. What does this one say? T is greater than 1/3. Where are both of these true? In this region right here. So we've got 1/3, t, 1/2. So this is the interval where both of these are positive. So that is a solution. We haven't looked at both negative yet, but because this was built off of the original slope being greater than 4, we know that one solution is an open-ended boundary of 1/3 and 1/2. That's one solution. It might be the only solution, but we have to check when both are negative. We have to investigate if that's possible, and if so, what interval of values is it possible with? So now we're going to try to assume that this numerator is negative. We're going to say negative 10t plus 5 is less than 0. We can bring over the negative 10t to this side. Adding 10t to both sides cancels it out over here. So now we got 5 is less than 10t. We want the t by itself. So divide both sides by 10. 1/2. Here's the case of the denominator being negative. 3t minus 1 less than 0. Move the 1 minus 1 over. 3t less than 1, divide both sides by 3, t less than 1/3. But we already had t greater than 1/2, and here's a picture to show that it's impossible for t to be less than 1/3 and greater than 1/2 at the same time. So it's impossible for both numerator and denominator to be negative. So that leaves the only case for the answer to the problem where the slope is greater than 4 is in the interval, the open interval, from 1/3 to 1/2.